Okie dokie. Let's see who turns up on this one. I need to get registered in a moment as well. Swing it around. Pretty red to me. Doesn't seem to be anyone at the moment. Let me send a quick message out. See if everyone's out there. It's got one person. It's probably Kelvin. No. Where is it? It's got two people. So what we're going to do is look at integration as probably now, this one's more like a tutorial, so more practice on it. I think I'm going to run a test either. Hey, good to see you guys. What I'm going to do is I'm going to test you guys on integration on Thursday. So what we need to do today is do a revision class on it. So that's what basically this is. We'll take as long as we need to. Let me grab hold of the book. And I'll start putting some headings up. So what I'm going to do is I'm going to write down the headings that you will be expected to be able to do. So let's go for the big ones. So that I'll have to think about. Probably more likely I'm going to send you the exam paper and you send me back answers. So the big ones are substitution. Parts. Thank you guys for all signing in. That's brilliant. Partial fractions. That's another one. Stuff like inverse chain. That's another good one. Trapezium rule. I've redone trapezium rule because I mean that might be one we want to try. And that's it, I think. Trig identities, possibly. So those are the big 6 things that will exist. So yeah, I'm going to give you a quick test. So what I want to know is, what do people want to see? What do you want to recap today? So you've got 6 titles there. So our mocks have been cancelled this year, pretty much, I think, unless coronavirus fixes up, which isn't likely. I suspect the mocks will be in September, if I had to guess, as far as I can see anyways. So I don't think there'll be any mocks, but I do want to do a practice test on Thursday on integration. We'll finally finish the integration chapter, other than differential equations. And with the differential equation stuff, I'll do kind of further math stuff with it as well. So differential equations is going to be like a little bit of year 2 pure, and then I'm going to teach further maths. So you've got a lot of time. Yeah, you do. So have a look at the list over there, and then start popping in the chat box what you'd like to have practice on. And on Thursday, I'm going to give you a test on those topics. So just to be clear on what you're going to be tested on, everything from page 293 to page 321 in the Pure 2 book. And I'll give you a minute because the Pure 2 book's what we're going to be looking at. There's nothing to stress about. It's just a practice test. If you do badly, we'll practice more. If you do well, we'll move on to differential equations. The world's not going to end either way. All right? Well, it may end, but not because of this. So pop in the chat box which ones of these you need to see. We've gone down to 4 people. I don't know what happened there. Maybe Wi-Fi slipping. So what you need to do is pick a topic that you don't like out of those 6, and then we'll go through it. The book we're looking at today is the Pure 2 textbook, and you'll be tested on anything from 293 to 321, but not today, obviously. All right, I still can't see any topics in the box at the moment. I'm just waiting on that. Reply about Trapezium Rule is, I mean, I'm not entirely sure whether I've taught it. I think I did, but I'm not sure. So if I haven't taught it, I'll teach it now. Let's get it over and done with. So if everyone turns to the Pure 2 textbook, and if you go to the Pure 2 textbook, you'll find what we're looking at from page 317 onwards, right? So page 317. onwards. And I'll show you very quickly. Yes, a trapezium rule. That's our first heading. Let's do that. Trapezium rule. Okie dokes. So the trapezium rule. Let me put that away. You can actually see. I don't know why that's behaving stupidly. Yeah, much better. No, I don't think we did either. So let's carve a trapezium rule, and let's make this lesson trapezium rule. So first of all, let me give you the formula. I want you to copy it down for me. So, which is the integral between b and a of y dx equals a half h y0 plus yn plus 2 lots of yn all the way up to yn minus 1, close bracket. Okay, so copy that out. I know that doesn't make any sense to you as it stands, all right, unless you've already seen trapezium rule somewhere else. But copy it down for now and I'll show you how it works. I'll show you a very, very simple example. So copy that one out. I'll give you like another minute. And then I'm going to demonstrate how to use the trapezium rule with a very simple example. Okay, I'm going to assume that you might take a little longer than that, actually, to be fair. So it says a half h. Let me just tell you while you're copying what h is. H is something called strip length, and I'll make sense of that in a minute. And is there any other thing you're looking at? Y's are just y coordinates, all right? Y's are just y coordinates, and that will make sense to you when I actually do it, all right? I'll give you about another 40 seconds to copy that formula out, then we'll do an example and it will make sense to you, promise. It's one of those things where you've got to see it done, really. Okay, that 10 more seconds on that copying out. Okay. When you come back, I mean, the video is going to be up there, so don't worry about that. Okay, let's roll. So, the trapezium rule is a method of working out area under a graph. And you might say, well, I could already do that. I can integrate directly between numbers. Why am I bothering doing this? And the answer to that is because some functions are difficult to integrate, and some functions are flat out impossible to integrate. Okay. In fact, I remember reading that there are more integrals that can't be integrated than those that can be. So there's more that you can't do than there are that you can do. The examples I'm going to use are actually things you can integrate. So it's not maybe the most profound examples, but they show you the method reasonably well. So let's take an example. Let us integrate. And this is something, of course, you can already do. Between 3 and 1, x squared dx. Now, you can all do this on a calculator. Yeah? That's fine. We already know how to do this, right? I'm going to show you the trapezium rule. Now, the point to emphasize with the trapezium rule is it's an estimate. Yeah? It's an estimate. So it's not going to be entirely as perfect or as accurate as a direct integration. Okay? So if we think about what this is, we draw the graph. Quick sketch. I mean, it goes that side as well, but I don't really care. That's 1, that's 3. It's this area, isn't it? Yeah, it's that area. And if we model that shape, so we just draw, I'm going to draw this in big size now. So this is your curve. We modeled it with a series of trapezia. So trapezium here, trapezium there, trapezium there. So we worked out the area of the trapezia. You've got an estimate for the area of the curve. All right? So I hope that makes sense so far. So how do we do this mathematically? I'm going to take you through it step by step. The first things first, right? they'll tell you how many strips to use, or they'll tell you how many kind of like, strips is generally the right word here. So I suppose I said, let's do this with the trapezium rule with 4 strips. All right. That means you're going to cut the gap from 1 to 3 into 4 separate parts. So here's my table. I'm going to start with 1 to 1.5 to 2 to 2.5. This is entirely numerical. 3. It's got nothing to do with that. Well, it's not nothing to do with that. Obviously, they're both integrals. But this is a numerical method. You're actually not going to do any integration at all. And what you do with those numbers, so it says 4 strips. So 4 strips will imply having 5 numbers. Because if we draw the diagram of this from 1 to 3, we'll then draw the curve. So that's 1, 1.5, 2, 2.5, 3. Yeah? So if I draw this, you've got a trapezium here. Draw that, you've got a trapezium there. Draw that, you've got a trapezium there. And draw that, you've got a trapezium there. So you've got 1, 2, 3, 4, 4 strips. So 4 strips implies you have these as 5 different numbers. All right? So everyone's reasonably happy so far. I can ask you to type in the chat box if you understand up to this point what you need to do. So they're telling me I'm integrating between 1 and 3. So I break 1 and 3. Oops, I do apologize. I break 1 and 3 into 5 separate numbers, which will give me 4 strips. So I'm just going to hold on a second, I'm not going to say anything more until people confirm that they're satisfied with the understanding on these points. Understood? Brilliant, that's 1. There's at least 5 other people on this. So I haven't seen Mirella, haven't seen Zarif, and I haven't seen Farhan. So those guys are getting marked absent as it stands. Can I re-explain the course? So step number 1 in trapezium rule, to do the actual trapezium rule itself, is that you look at this and go, okay, it's from 1 to 3, and it tells me to go through 4 strips. So I'm just thinking, okay, let me split 1 to 3 into 4 strips. I'd go 1 to 1.5, that would be a strip. From 1.5 to 2, that would be a strip. 2 to 2.5, that will be a strip. And your 4th strip is between 2.5 to 3. All right? So if I just draw that as a diagram, so imagine this is your curve. Draw the axes, draw it like this. Imagine this is 1, 1.5, 2, 2.5, 3. Yeah? Right. You should not be using a calculator to do this because that's not trapezium rule. So why the heck? Yeah, okay. Because trapezium rule is an estimate thing, right? You're not meant to be using a calculator to integrate this. That's not what it's asking you to do. Yeah, I'm trying to teach you trapezium rule, all right, which is not using a calculator for that. All right, I hope that makes that clear. And then 3. Let me quickly draw the diagram a bit better. There we go. Yep, 1 strip, 2 strip, 3 strip, 4 strip. Okay. Is it true that number of strips is upper bound plus lower bound plus 1? No. Number of strips is as many as I like. It would be 45 million if I wanted to be. Okay? I picked 4 strips because numbers work nicely. There is no rule to the number of strips. The question could literally ask you to do it 2 strips if you wanted to. However, it is true that the more strips you've got, the more accurate you are. And that's worth knowing. So I suppose that was a good question. Okay? Is everyone now understanding what you've been asked to do? As in, like, if I've got 4 strips, I'll break the region from 1 to 3 into 4 strips. That's all I've taught you so far, nothing else. I've given you the formula, which we'll work on, but as of now, in terms of the mathematics, that's all you need to understand. Can you put a confirm in the chat box for me? All right? You got it, Imam, well done. Yep, Reebok, good. Kaisan, good. So still waiting on 3 more people. Two more. Okay, let's move on. So what do I do with all these x's? I substitute them into the formula. Okay? So y would go, okay, this one's 1, that's 2.25, that's 4, that's 6.25, and that's 9. Okay? So all I did was square it. So to get from the x coordinate to y coordinate, I just substitute it. Yeah? I did not integrate it and then substitute it. Let me make that absolutely clear. It's not 1/3 x cubed, it's literally just x squared. And each one of these is now a value. This is y0, y1, y2, y3, y4. Okay? Because that's the first one, and that's the last one. 1, 2, 3, 4, 5. Yeah, 0, 1, 2, 3, 4, sorry. The y looks like a 4. Which one? This one? Oh, there you go. Yes, x and y. All right. Okay, cool. They're y's. Happy? All right, cool, cool. Is everyone happy that those are y's? Let me rewrite them if people are struggling. So y0, y1, y2, y3, y4. There we go. Happy now? So I'm going to move on in about 30 seconds. No problem, River. I'm going to go on 30 seconds and explain to you the very last step of this, because this isn't really hard. If you understand this and write this out step by step, it's something you can just do over and over and over again. All right? Ten more seconds. Anyone got any other questions before we move on to the next part, which is the last part of this? Okay, let's roll. So the formula goes, and if you, this is something you hopefully had written down already. H over 2, or half h, y0 plus yn plus 2 lots of y1 to y. Remember, this is not just y1, it's all of them to n minus 1. All right, so that was your formula. Okay? We all good so far? Excellent. So h is merely the gap between the x's. So here, this is going to be a half. So h over 2 will just come out as a quarter. So it's 1/4. You can't see that well. Can I ask you to copy this down? I'm just going to refresh the whole thing. I'm just going to rub out that line. Okay? So can you clear up this line for me? Copy out this line, the one I'm pointing out, and this line. Okay? And then we're going to move on. And I'm going to move on in 18 seconds. Okay, so we know what the formula is. It's h over 2. The h is the gap between x numbers, so it's going to be a half. So half over 2 is a quarter. Then you pick the first and the last values. So here it would be y0 would be 1, and y4 would be 9. And then it's 2 lots of every other number added together. So 2.25, 4, and 6.25. You work that on your calculator, and that gives you an estimate of the area under the graph between 1 and 3. Okay? So can you work that on your calculator for me? and then pop it in the chat box. All right. You got 35/4. Let's see where everyone else gets. Same? Okay, good. Now, there's one last thing I need to show you on this anyways. And that's the idea of the fact that this is an estimate. Yeah. So how accurate is it? Because if you do the integration itself, do it on your calculator now. Let's do it together. So the integral of between 3 and 1. Between 3 and 1 of x squared. So x squared. Oops, a daisy. That's 3 and 1 there. So integral 3 and 1. Put it here. X squared. And you get 26 over what? Really? So you got 35/4, 26/3. So 26/3 is 8.6. So the actual answer for this is 8.6 recurring. And you got 35/4, which gives you 8.75, which isn't massively off. So, sorry, you can't see that well. 8.6 recurring is what it actually is. And this estimate here gives you 8.75. All right, so that's not massively off. That's not massively off. It's a bit off. It's about 0. Well, it's less than 0.89, sorry. Yeah, so it's close. All right. There is a measurement for how close it is, and that's called the percentage error. So assuming everyone's got this method now, yeah, and if you don't, you need to say so. In fact, let's just take a little stop here. You got 30 seconds. If you do not understand how to do this, can you say so now? No, I'll tell you why it's not accurate, but it's not because, are you talking about at the top of the curve? Well, maybe. We'll come on to that in a minute. Do you understand how to get the number 35/4 though? That's what I really want to know as of now. I'll explain the rest of it. You got this, good? That's excellent. Where does the 1/4 come from? Okay, basically it's the h over 2, all right? The h, the gap between the numbers, is a half, and a half divided by 2 is a quarter. A half divided by 2 is definitely not a third, my dude. All right? So it's going up in halves, yeah? So h is a half. If you half a half, you get a quarter. All right? Anyone else got any particular issues on this part of it? Because there's stuff I need to talk to you about accuracy. You got it now, brilliant. Well done, well done. Okay. Anyone else got any particular issues? I mean, yeah, let's just move on. Okay, cool. So 2 questions come out of this. First of all was Kai-san's question. Why is it inaccurate? And it's because a trapezium doesn't really mirror the shape of a curve perfectly. So here we'd have an underestimate. Okay, you'd see the line of it is here, the curve is slightly above it, you're going to get an underestimate. Yeah? Actually, hold on a minute. Depends how you draw it. If that's there and that's there, it might be an overestimate. Okay, so hopefully that makes sense to you. Oopsie-daisy. Right. So there will be inaccuracies. And here, we did get an underestimate. So, the last thing we need to know is something called percentage error. Okay. We got 8.6 recurring for the question, but when we integrated, didn't we get 8.75? So when we did this, we got 8.6 recurring. But when I did the integration itself, I got 8.75. Actually, hold on, which way? Let me just see. I'm just going to go back in the chat and see who's right. It was an overestimate. Okay, cool. I take that on board. Okay, cool. So overestimate it was. Anyways, how do you work out whether it's accurate or not? How accurate is it? We do something called the percentage error formula. All right, got it. Thanks. Well done, Kai-san. Well done, Iman. So if it was an overestimate, the actual would have been 8.6 recurring. Yeah. Take away what you actually got, so 8.75, and divide it by the actual, and then times by 100. And that's the formula for percentage error. So I'm going to write that out in words. It's actual minus estimate over actual times by 100. I hope that makes sense. It won't make sense if you can't see it, but now you can, I think. Okay, so that's the last little bit of that. So if they ask you to work out how wrong or how inaccurate it was, you can use the formula, the actual value, so if you do the integration properly, minus the estimate, divided by the actual, times by 100, and that will give you the percentage error. Okay, so what I'm going to do is I'm going to hang around again for another, say, 2.5 minutes. The exercise I want you to do, and I'll say, maybe on Thursday we won't do the exam, then maybe we'll do a test after half term. We'll do a revision lesson on Thursday. The exercise I want you to do for now is 11I in the Pure 2 book. So this is second year Pure 2, 11I. Okay, and that's on page 319 to make it absolutely clear. What does it say on top? Percentage error. Just that's what it's called. That's the formula for percentage error. So it's page 319, 11I, and then on Thursday we'll do an integration revision lesson, and then after Easter we'll do a practice test on the Monday. Okay, so that's about 3 weeks away now. 3 weeks exactly now. So what we'll do is I'm going to hang around here for about another minute or so, minute and a half. If anyone is struggling with any of these concepts, this is the time to ask me questions. When is holiday next week? Oops, sorry. So half term's next week. Not half term, full term actually, Easter. What will happen at the end of your mocks? Probably in September now. I think that will be the reasonable thing to do here. So I'm assuming, because there's no response at the moment, people are happy with this. If anyone needs any further help, just pop it in the chat box. But The exercise is 11I. It's in the Pure 2 book, page 319. And that's your lot for today. Next Thursday, so this Thursday coming, we'll do a full-on integration revision lesson. All right? And then your integration test will be after half term. Hope that makes sense, and I hope everyone's happy with that. Okay? Take care. And that will be that.